So we've already seen one way to express the slope of the tangent line to a curve in terms of a limit. So if we imagine we have some function and we want to find the slope of the tangent line at point P. So that would look something like this direction here. But the way we do that is we pick another point, maybe point Q, and then we allow point Q to get closer and closer to point P. So in order to do this, it helps to define some things. Maybe we'll say that point P has an x coordinate of a, which would make this over here f of a, assuming that we have this function f of x here. And then I could call this x coordinate x, and then this would be f of x. And the reason I use x here is because I'm thinking of this as a variable. X is the thing that's changing. It's going to get closer and closer to a as q gets closer and closer and closer to P, and this secant line will approach the tangent line. So this was the equation for the slope of the secant line. It's a change in y over change in x situation here. So we have f of x minus f of a, that's your change in y, over x minus a, that's your change in x. But if we let x approach a, then we get the slope of the tangent line. And so that would be the limit as x approaches a of f of x minus f of a divided by x minus a. Well, it turns out there's actually another way to express the slope of the tangent line. So let's start over here and we'll look at our curve once again, except this time I'm going to use a slightly different notation. So again, I'm going to let the x coordinate of point P be a, and this time I'm going to let this x coordinate be a plus h. So what that means is this distance right here between these two x coordinates is h. And so then this would be f of a still right here, and then this would be f of a plus h. And so again, I'm going to let the point Q get closer and closer to the point P, but this time what would happen is that this distance h would go to 0. So in equations, this would look like our secant line. Slope of the secant line would be, again, our change in y over change in x. Now the change in y makes sense. That's f of a plus h minus f of a. But the change in x is just h. Well, why is that? Well, look at what we have for the x coordinate here. We have a plus h, so that's a plus h minus a. And that's just h. So that's where this h down here comes from. And then if I let h approach 0, I get the slope of the tangent line. And so that would be the limit as h approaches 0 of f of a plus h minus f of a all over h. Let's look at an example. So here's the equation for the tangent line. Now this is our alternate expression, for the slope of the tangent line, I should say. And then we want to find the equation of the tangent line to the function f of x equals 2 over x plus 1 at x equals 3. So here's a graph of this function. It has an asymptote when x is negative 1, a vertical asymptote. And we're looking at the tangent line right here. So we want to find the tangent line at this point. And so the coordinates of this point are 3, and then if we plug in 3 here, 3 plus 1 is 4, we get 2/4 or a half. So a half is the y coordinate here. You can see that looks to be about a half. Okay, and so now we want to use this expression here to get the slope of the tangent line, and then eventually to get the equation of the tangent line. So let's do that. So we have the slope of the tangent line, m tangent, is going to equal the limit as h approaches 0 of, so f of a plus h. Well, what's a here? Remember, a is the x coordinate here. That's 3. So let's just make a note here. A in this case is going to be 3. So this is going to look like 2 over, and then in place of the x here, we're going to put a plus h, or 3 plus h. So that's going to be 3 plus h plus 1. And then we have minus f of a, or f of 3. So that's 2 over 3 plus 1. And that's all over h. Okay, now we just have to do some algebra on this. So this is equal to the limit as h approaches 0 of, and I have a 2 and a 2 here, and then an h down here. I can kind of factor that out. Maybe I'll just put that out front here. and then worry about everything else. So what would be left over? Then I would have 1 over, and this is 3 plus h plus 1. That's h plus 4. And then this would be minus 1 over 3 plus 1 is 4. Okay, and so this equals the limit as h approaches 0 of, well, I can't plug in the 0 yet because I'd have a problem right here, but maybe I can work on this a little bit and see if I can get the h's to cancel somehow. So let's add these or subtract these two things. I need a common denominator. The common denominator will be 4 times h plus 4. So I still have my 2 over h up front, and then here I'll have a 4 times h plus 4 in the bottom. And then what will the top look like? So I would need to multiply this by 4 on the top and the bottom, so that'll give me a 4. And I'll need to multiply this by h plus 4 on the top and the bottom, so that would give me an h plus 4. Okay, and so now we can try and simplify this a little bit. So I have the limit as h approaches 0 of 2 over h, and then I have 4 minus h plus 4. Well, the 4 and this minus 4, when I distribute the minus sign, those are going to cancel. So I'll just have a minus h up here. So I have that up top, and then I have 4 times h plus 4 on the bottom, and now I think I have something nice here. These h's will cancel, and in fact these 2's can cancel here. I have a 2 left over there. And so if I do that, what do I have left over? I have the limit as h approaches 0 of, so I have a minus 1 up top and a 2 times h plus 4 on the bottom. And when I plug in for the 0 now, I get negative 1 over 2 times 4, which is 8. So I have negative 1/8. So that's going to be my slope of the tangent line. Now let's actually get the equation of the tangent line. Okay, so we just found out that the slope of the tangent line was negative 1/8. That was from the limit here. And we also have a point here on the line. It was the point we found before here. It disappeared, but that was this point right here. That was 3 comma a half. So that's a point that I know is for sure on the tangent line. So positive a half. So between the slope and the point, I should be able to get an equation for the tangent line. So I know the general form for a line is y equals mx plus b. So I can plug in the slope, that's negative 1/8 x plus b. And then I can use the point to solve for b. So this will be 1/2 equals negative 1/8 times 3 plus b. And if you solve this for b, you end up getting b equals 7/8. And so my final tangent line equation here is negative 1/8 x plus 7/8. So we found an alternate expression for the slope of the tangent line. And sometimes this expression is a little bit easier to work with. So when you're approaching a problem, when you have to find the slope of a tangent line, take a look at both expressions and see which one makes the most sense to use for that problem.